So hello and welcome to the Motion Toolbox user tutorial. First, let me present a bit myself so you know at least who is talking. So I'm Tutor Links and I'm working in Leuven in the Drivetrain in Motion's technical domain. Let me start with a small disclaimer. So today I will only explain on how to use the toolbox, but I will not start to explain the full theory behind the toolbox, how it was developed, what is the complete framework behind it, and so on. For that, I invite you to look at the KDM of January, where we presented the hyperdrivetrain toolbox. So you can find on Confluence the different presentation, but also a recorded video of the meeting. So as I said, today I will explain a bit on how to use this toolbox. We will first start to see on how to get access to this toolbox located on the GitHub repo. Then we will see on how to set a project environment integrating this toolbox. Then we will see on how to start modeling by using this toolbox. And finally, we will see also on how to push, clone, and pull on GitHub to work with colleagues on the project using the toolbox. Finally, I will also list a bit what will be the next video where we will go further into detail on the different possibility that you can have with this toolbox. So first, we need to get access to that toolbox. So the toolbox is located on the GitHub repo. And so for that, you need to create a GitHub account. For that, I invite you to look at the Confluence page explaining on how to start to use GitHub, but also especially on how to create an access within Flanders Make. Once you have your access, you can start to ask to the Motion Toolbox email address to get access to the toolbox. So for that, you can simply send a mail to the toolbox address. And in this mail, you will have to specify also for which project you will work. So here we create a fake project called Motion Toolbox Tutorial. It's quite important because the admin will create a branch especially for you. So in that way you can work in this branch without interfering with the stable main branch. So, and then you will receive a response from the MotionS admin saying that they give you access to the toolbox and they created a branch for you. So now you can see that on the GitHub website you have access to the toolbox. And so with the different folder that we will see after, and you can see that there is the main branch, so it's the stable version. And now they created a copy of this, so you can see there is also a lot of other branch we are made for the other project. So it means that each project can work in its own branch, so like creating customized blocks for them without interfering with the stable version of the toolbox. So now it means that we'll start to work on our own branch. The GitHub environment is ready. We will see how to set up our complete project environment. So if you want to have more detail or if you are bumping into any issue, you could still have a look at the following PowerPoint, which is also explaining most of the procedure. But I will now explain all of the main one and how to create our project environment. So first we will have to create our own GitHub repository. Then we will have to link our own GitHub repository to the Motion Toolbox repository. For that we will create a submodule. I will explain now how to make this and how to create that link. Then we can check a bit if all the environment is ready, so if everything is correct. And then we can start to create a simple Matlab project. Once we have our simple Matlab project, we can finally link this Matlab project to the Motion Toolbox project. So first, you create your own GitHub repository. For that, there is nothing really new. So in the Flanders Make repository, here it will be the Motion Toolbox tutorial. So now we have our Motion Toolbox tutorial repository, which is actually empty. From this one, we can create a local version, so on the local computer. So you can just copy the HTTPS link, and in your favorite Git local repository, you can just clone this repository. Now, the repository is cloned on a local version, so you can then find it here. Once we have our local version, we can also set it in source tree. So in source tree, we can just add a new repository here and give it the path to the local version. That's it. So now we have our source tree repository. We will use this one later to create the module, push and pull, and so on. So now that we have our own tutorial repository, we need to link it to the Motion Toolbox repository. So for that, you can do a right click on the left here and add a submodule. You need a source path, so for that, you can navigate in the GitHub website to the Motion Toolbox repository. To copy the HTTPS link and paste here for the submodule. You will create directly the relative path, which is called Motion Toolbox, and you will add the submodule. Quite heavy. This step can take a few times, like few minutes. Okay. So now the submodule has been added. We can see that we have some stage file that we have to commit. So you can create a commit. Here you can simply specify that the Motion Toolbox submodule has been added. And you can commit this and then push. Here we are still on our tutorial repository. Okay, so now on our tutorial repository, we can see that we have a submodule link here. If we click on this one, then we pops up on the Motion Toolbox repository. As I said, now if we are in the tutorial repository, we can pops up on the Motion Toolbox repository. However, we pops up on the main branch, and we don't want to work on the main branch because we want to keep this one stable, the project. For that, we need now to check out to the Motion tutorial branch. So we can simply check out to this branch, and now we are on our own branch, which is actually just a copy. Now, if I go back on my tutorial repository and I click on the link, I pop up on the MotionS tutorial branch in the Motion Toolbox repository. Now we can check a bit if everything is correctly installed also locally. You can navigate in the folder of your repository, so here on the tutorial repository, and now here we can open the terminal and also use some of the GitHub command to check if everything is okay, like git status. You can see we are now main branch of our tutorial repository. And we can see we have a new folder here, which is the complete Motion Toolbox with all the file and all the source files of the toolbox. Again, in the command, we can navigate to this folder and do a git status here. And here we can see that we are on the Motion tutorial branch of this repository. So now we have two GitHub repository, but they are both linked together. So on source tree with the link, but also locally. Now we can also check in Matlab. So in Matlab, we can also go to the Motion Toolbox and check if the toolbox is correctly installed. So for that, you can launch the project of the Motion Toolbox. So it will load this project. As I say, the project is quite heavy, so this step can take a few minutes. So yeah, now the project has been loaded, and we can see here we have a small issue. Some of the example was not on the path, so it's not a major issue, so we can simply ignore it. But we can see that the complete Motion Toolbox has been installed and all the path has been set. it means that now we are ready to create our first MATLAB project. So now we go on our tutorial repository and we can create all the folder you are basically using when you create a MATLAB project, like architecture, data, results, scripts, and so on. Then from that, you create a new project in MATLAB, and you can set up your project like adding path to all the folder of your project. So you should not add the path to the Motion Toolbox yet. Here is really a very simple project. So we can see we can quite fast launch it. So as I say, we don't need to add a path to the Motion Toolbox in our MATLAB project, but we can simply link the two MATLAB projects together. So for that, we start from our tutorial project. In the project tab, we can add a reference here, and we can browse here to the Motion Toolbox and select the Motion Toolbox project. We can add this one. It will again launch the Motion Toolbox project, which can take a few minutes. Okay. So now, if I launch the tutorial project, we can see it will launch the both projects. So it will launch our tutorial project with all our small folder, but you can see it also started the Motion Tutorial project. So it means that now we are ready. We created two GitHub repositories, so we clone the Motion Toolbox, we create our own GitHub repository, we link it both together with the same module, we created our own MATLAB project, and we linked our MATLAB project to the Motion Toolbox project. Everything is so now that our modeling environment is ready, we can start to make model using the toolbox. For that, I will first explain the small mechanical example we will use within that tutorial and how to model it using Simulink Simscape environment. Then create this model, and we will use a component coming from the Motion Toolbox. After that, we will see how can we initialize the component coming from the toolbox using Excel data files. And finally, we can run this simple model. So the model we will use for the tutorial is the following one. It's a really simple powered slider crank mechanism. So first, we will have a crank here continuously rotating. It could be powered by an electric motor, for example. Then we will have in green the slider crank mechanism, which is converting the rotating motion into a translating motion. And finally, we can have here purple a load that we have to move back and forth. In order to make it a little bit more complex, we will also use the modular approach here. So it means that we start from a benchmark, which is here an electric motor connected to the slider crank mechanism, and then the output connected to a translational mass. And instead of using one module, we can, for example, using two modules here. So that means we will use one electric motor and one slider crank, and another electric motor and another slider crank, again connected to the same translational mass. If you want to learn more about the benefit of this approach, I invite you to have a look at the modular project. So here now, small word about how can we do this in the Simulink Simscape environment. So our small mechanical model. So here the electric motor will be simply fed as an ideal speed source. So in that way, we don't need to take care about the modeling of the electric motor, but also all the control sides. So we can just simply send a speed target ideal speed source. Then for the slider crank mechanism here, we will use the slider crank coming from the Motion Toolbox. And finally, we can just use a simple translational mass from the Simscape library. So now we can start to create our Simulink model. So in our tutorial folder, in the architecture folder here, for example, we can create a Simulink model. So we can save it in the architecture folder with a small name for the tutorial. We can start to modeling our Simulink Simscape model. So first, we will need a solver for this Simscape model. Then the second step is to add the ideal speed source. So here we use component from the Simscape Foundation library. In the mechanical source, we can source. So as I say, we will use the modular approach. So we will now use two ideal speed source. So they should be connected to a mechanical rotational reference. Then we can connect our solver to this Simscape model. Then we need our speed target. So for that we can use a constant. Here it will be in radian per second for the speed. And we can simply use the same target for our two ideal speed source. So here we create the first part of our really simple Simulink model. Now we will have to add the slider crank mechanism. It's coming from the MotionS toolbox. For that, we start from our Motion Toolbox tutorial GitHub repository, and we will navigate directly into the toolbox. So we go into the toolbox, and here we have different library for electrical component, mechanical, thermal component. So here we use the mechanical one, and we have directly the library here. So you can see in the library there is several mechanical systems like compressor for bar mechanism, vehicle, driver, and so on. And here we will use the slider crank. So if you click on it, you can see a small description of the component if you want to learn a bit more about it. You can see also the different parts that are used. So we have the crank and the pin, so the slider. If you want to learn a little bit more about it, you can also go in the toolbox. In the source file, here you can find the source file of the slider crank. So it's to create the slider crank object. Here you can find the different properties of the component and the different function linked to that object. Then in the contrib folder, here you can find some example. For example, if you want to learn how to use the slider crank, here there is an example on how to use the slider crank. There is one Simulink file, which is here also a really simple example with the slider crank connected to an ideal torque source and with a load. Then you also have a script explaining how you should initialize this component to create your slider crank object. As a reminder, if you want to learn more about this approach, you could have a look at the KDM presentation. So here we can see for to create the slider crank object, it's linked to an Excel file. So in the data folder, you can find also some Excel file example here. And so here, the Excel shows the different properties of the component and give already some initial value that you could use for your slider crank. So now that you know a little bit more on how to use the slider crank, you can add it to your model. So here we use from the library, so we do simply drag and drop, and we will use two of them, so you can drag and drop 2 times. And now we have our model from the library, so we can continue to create our tutorial model. So we connect the crank to the ideal speed source. The crank also needs a mechanical rotational reference, so you can connect it to this reference. Then there is data output, which is giving some information about the crank, like crank speed, slider position, and so on. For the moment, we don't need it, so you can simply connect it to a terminator. And we have the pins, so the output of the slider. And we will connect them to translational mass that we will have to move back and forth. So we can, for example, one mass for one of the slider, another mass for the other one. And then as I said, for the modular approach, we would like to have one main mass that we have to move back and forth, so we can connect here our two mass. We can use a translational spring and a translational damper. So in that way, for example, we can emulate a long load that we have to move back and forth, and with this spring and damper, we can emulate the stiffness of this load. So you use component directly from the library, or if you know the name, you can directly type it here in the Simulink. Okay, so now you can see that our Simulink model is ready. So we have our two ideal speed source, our two slider crank, and they are connected to a common load. In the slider crank, you see they are still red. It's because as an input, they need a slider crank object. So here, for example, slider crank 1, and for our second slider, we will also create another object. It will be slider crank 2. Now, in the next step, we will learn on how to create those objects. First, to create those objects, as we see. So in the example, we need to create Excel data file. So for that, we can go in the Motion Toolbox, in the Mechanical folder, in the Contribution folder, and in the Data. Here we have some example of Excel file. Here we get the correct rank, so we can just copy and paste this Excel file, and we can paste it in our data folder or the tutorial GitHub repository. In order to not have too much confusion, we can also just rename our data file. So it means that now we can work in this data file, which is our own data file from our own GitHub repository without inter. Here we have the first sheet called S3 modular with all the properties and the value of the slider crank. They are linked to symbols. Those symbols are used in the Simulink Simscape environment, and we need also to specify the units of those properties. So here we have the different length of the slider crank, the mass, and inertia. And so here we have one slider crank, but as I say, we will need two slider cranks. So for that, we can create a second sheet. We can rename it. So that's up to you to select the name of your sheet. So that means each sheet can be used either for creating new component, or if you want to test the same component but with different properties value, you can just simply create as much sheet as you want, and when you initialize your component, you select the sheet of the properties you want to test. Okay, so now that we learn how to create an Excel file, we will see how to use this Excel file to create our Motion Toolbox component. So now we are in our tutorial repository, and in the script, we can, for example, here create our own main script that we will use to initialize our component. So here, we can create a section where we will initialize the component coming from the toolbox. And so if you don't know how to do it, as a reminder, we can still have a look in the Motion Toolbox, in the Mechanical folder, And in the source folder, we can have a look at the slider crank object to see how is this object created. So here we have script for each folder, for each component. And so for the slider crank, we can see what are all the properties this object needs. And we can also see the function that is used on how to create the slider crank. So we can see this function needs a name, so that's a name that can be used in your Matlab or Simulink Simscape script. Then you need a database, so it will be the Excel file we just created, and a sheet. So that's, for example, one sheet for each component that can be located on the same database. And once again, we can also look in the example, so in the example of the slider crank, on how is this script used to create the component. So here we see they create the slider crank 1, also called slider crank 1, using a database and a sheet in that database. So we can just copy this, use the same approach in our main script. So we will have our slider crank 1 object that will be used here in the Simulink Simscape model. And then we need to link it to a database. So that's the database we created for our own project, which is in the data folder or the tutorial repository. So here it's called slider crank tutorial. Yeah, we can just modify the name of the database. And then so is our first component, which is called here for the sheet. So we have two sheets for the two components. And we have the sheet and slider crank modular one, called SC modular. And then we can just create a second line for the second object, which will be the slider crank 2. So the name is also a properties of the object that can be used whenever you want in your Matlab script. And here we will link to the datasheet of object 2. And so here, this object 2, we made a slider crank with a slightly higher mass. So in order to not have confusion, so we have two different here components, so that we can also see in two components are correctly used. So if you run this script, you can see that two objects are created. And then you can look at this object. So he created an object, and you can see he added all the properties of this object, link it to the database we made with the sheet SC modular, with a name, and yeah, with all the properties with corresponding value. We also have the same for slider crank 2 with the sheet 2, and you can see the mass is slightly higher because we use a sheet where we enter the mass slightly higher. Now that we have our two components created, you can just continue to create your main with all the different scripts you need to initialize your model. Here our model is quite simple, so we didn't look at the time step and so on of that model. And so here we can just add a simple line to open our Simulink model from the Matlab script. And so now we have our model, which is ready to run. So now our two components are not ready anymore because now they are using the object that we created in the workspace. And finally, we can simply run our model. So for that, I just extracted some data from the data signal that we can plot to have a look at the model if everything is running fine. So we can just run it. So quite really fast as it is a really small model. So we can velocity, so what we extracted from earlier, our crank is linked to a ideal speed source with a speed target of 1 million per second. So here we can see our two crank are rotating continuously at 1 million per second. Then we can look at the slider position. Here we can see that the slider position is correctly doing a movement of back and forth. And finally, we can look at the mass, at the force applied on the shaft. So the shaft connecting the crank and the electric motor. And as one of the crank has a slightly higher mass, we can see that one of the forces is slightly higher. So that's it for this simple Simscape example. Okay, so now that we see how to create our own model using some component from the Motion Toolbox, we will see how we have to deal with GitHub here. So to pull, push, and clone. Also see how to work with colleagues using the Motion Toolbox. So let's start by the most easy things. For example, a colleague wants to start to cooperate with you on the tutorial. So he will have to clone the GitHub of the tutorial. Here he will clone the main repository of the tutorial toolbox, so the one we created by ourselves. But he will also have to include the submodule from the Motion Toolbox. For that, there is two ways to do it. In source tree, you can your submodule option, or if you are using the command line, you need to add the argument recursive. In that way, when you will clone the tutorial toolbox, the tutorial GitHub, it will also clone automatically the Toolbox tutorial, create the submodule for you, make the link, and so on. So you don't need to restart all the steps I shown before. And so when you clone a repository, it always starts at the main. So again, here we will have to go in the Motion Toolbox and check out the correct branch, so the branch of the tutorial on which we are currently working. So how it works, we are here in the tutorial, so I give access to one of my colleagues. So my colleague, for example, would like to clone the complete tutorial. Here we have with the slider crank we created before. So just need to copy the HTTPS, and then we can go on the GitHub of a colleague, let's say. It's the local repository of the colleague. We can open a terminal, and here we can git clone. And as I say, we need also to add the submodule, so we need to use the argument recursive. So with this argument now, we can clone. And so here, it will again take a little bit of time because we also need to clone here. Clone the tutorial, so with all the file from the tutorial itself, so the slider crank we created, but now we also start to clone the submodule Motion Toolbox, which is a little bit heavier, so it takes a little bit more time. Okay, so now the repository has been cloned, so we are in the GitHub of the we are in the local repository of our colleague. And so here we can see that everything has been cloned correctly. We have the submodule, we have all the data from the tutorial, and we have here the Motion Toolbox submodule already linked for our colleagues. So here we find again the complete toolbox. And so once the cloning is done, it's not shown here in the video, but the colleague should also not forget to check out the correct branch in the Motion Toolbox as it was shown at the beginning of the tutorial. Okay, so now we will see how to push. So here we are again looking at your view, so the guys who create the tutorial. So now we want to push something on Git because we were working on the tutorial, we were working on the toolbox, and we want to add to push our change on the GitHub, so our colleagues are also aware of this. So here is the complete framework. So we have the Motion Toolbox. the Motion Toolbox as a local repository and also a GitHub repository. Then we have our tutorial, which is also with a local repository and a GitHub repository. And then both are linked together thanks to the submodule link. So the guy who created the tutorial is currently working on his own local repository. And then he will have also to push a few things to the repo, so that means other colleagues can pull and work with the new update. So now we will see how to push things from the different repo, either the toolbox or either the tutorial. First, we worked in the tutorial, so we create new component. Like for example, we created the translational mass with some stiffness and damping. We create our model and so on. We used some component from the Toolbox library. So we use, thanks to the library link, we drag and drop a component from the library, which was the slider crank. And then, for example, we could also have made modification to this slider crank. For example, the equation in the slider crank are not the one we want, so we can make some modification of this component. It was not done here. It will be for our next tutorial. But let's say that we made also change in the toolbox itself. So it means that now we have change here in the toolbox. We have change in our tutorial, and we need to push all those things so our colleague can also work with those new updates. First, we will need to push from the toolbox. It's important to first do the toolbox before the tutorial. So first, we commit and push our change of the toolbox. It means we will have a new updated GitHub repository here. We can commit and push the change we made in our own component here. And then finally, here we have some change. So we have an updated repository, but it's linked with the thanks to the submodule. And it means that we will have also to commit and push the updated repository here, to finally have a final updated repository of our toolbox. But we'll take into account the change in our tutorial, but also the change coming from the Motion Toolbox. And once we are here, our colleague can work then with this new updated repo. So it's also important to notify your colleague that you made a change to the toolbox, because otherwise they will continue to work with your version of the toolbox, which is not the same, and at some point you could have some merging conflict. So we will now see how it works technically. So first, we start here in source tree in the tutorial GitHub repository. We can navigate to our Motion Toolbox submodule, and we can see that here we have an unstaged file. For example, because I made some change in the slider crank library, so we need to stage it. Then we can go in the file status. You can see that our file is staged, and we can make a commit. So for example, we made some modification of the slider crank mechanism inside the Toolbox library. So we commit our change, and we can push it still to our own branch, the Motion tutorial, because we don't want to push on the main branch. Now that is done, we can go back again to our tutorial repository, and here we can see we have two unstaged files. First, we have the mechanical system we created for the tutorial here, which is unstaged, for example, because we made some change in the ideal speed source or in the custom translational load we use. So we can, for example, just commit this stage this one and commit it. So we made some modification of some custom component in our own project. We can commit this, and we can push this. Here is on the main our own project. And now we can see we also have another unstaged file, is the Motion Toolbox. because in fact we made some modification of the slider icon and we push it. So now as we push it, it appears here. So we also need to have an acknowledgement of this in the tutorial repository. So for that we can stage this file and also commit it. And here we specify that we made an update of the MotionS toolbox. We can specify what was this update. Here it was a modification. We can commit this. And finally, push. So it's really important each time you made a modification in the toolbox, but you also then push here. Otherwise the file will be unstaged and the link between your repository and the toolbox can be broke. Okay, so now that everything has been pushed on Git, we can again look at a colleague side. So now that our colleague before has cloned our project and now we made some modification, and now he has to pull those new modifications to continue working with us. Here, in this way, we have to do the opposite. We will first have to push the change in the main tutorial repo, and then pull the change in the Motion Toolbox repo. So here we have source tree, and we have two tabs here, so the tutorial and the Motion Toolbox. That's for the main person, so the guys who created the tutorial. And here is the two tab to emulate the colleague, so that's the source tree of the colleague. First we are in our colleague. We can see he has already some modification, but if we go on the main guy, we can see he has modified the custom component and modified the toolbox. Here's the number test2 because I have to do it a second time. And we can see those two, the test2 are not yet in the source tree of our colleague, still missing those updates. And also in the motion toolbox of the colleague is also missing this update of the slider crank test2. So first, you will have to pull in the tutorial repository. Here, our colleague can pull. Now we can see it has the modified custom component block, the test2, and also the toolbox. But we see that we still have some uncommitted change with the motion toolbox. So here we have to pull also again. And now we can pull here, we see that we received the test2, and now everything is correctly pulled. We don't have any modified file anymore. So here we learned all the basis to use the motion toolbox and also deal with the GitHub environment. In the following video that will be created, we will also learn to add new property or parameter to a component, but also to create a direct new component from scratch. We will also learn, for example, to update our own toolbox branch with new development that has been done on the main, if it's a really long project and that we want at some point to update our own branch with the new features. And it could be also in the other way around. See, if at some point during our project we developed a really new or interesting component that could be added to the toolbox, or if we made a big improvement of some component that already exist, we'll also learn to merge our own branch within the main and or the development branch of the toolbox. So thank you very much for listening. I hope this tutorial was interesting and useful for you. And so I hope that you will soon start to use the toolbox. So for that, do not hesitate to contact the Motion Toolbox address. If you have any issue or question regarding that tutorial, do not hesitate to contact me on my own address. And otherwise, if you have any issue or question with the toolbox itself, do not hesitate to contact the admins on the Motion Toolbox address. So thank you for listening again, and goodbye.